coils. Either you can write increase current in the battery. Got it? Current in battery. Yeah, current through by battery in the coil. Like though, the best thing is in coil. Okay, is it clear to you?
Yes, sir.
Okay, then state the effect of on the motor reversing the connections of the battery. So when the current is reversed, I told you force is reversed by either B or I. So you are reversing the current. So force will be reversed. So direction of motion will be reversed. Is it? Direction of motion will be reversed.
Can I just write direction will be reversed, sir?
Um, Actually, it is said that the effect of state the effect on the motor. So you can say rotation will be reversed, right? Or you can simply say rotation is reversed. Rotation is reversed. Okay, is it clear to you?
Yes, sir.
Okay. नेक्स्ट पे हम लोग बात कर लेते हैं. Yes.
Okay. The
हाँ.
battery in figure 9.1 is replaced with a resistor. The coil is made to rotate by an external mechanism. Explain why there is a current in the resistor.
Yes. So now you're doing what? You are going to connect this coil with the help of a resistor instead of you know making this, or instead of using this as a battery. This is now behaving just like a uh, just like a generator. Okay, is it clear to you? So
Yes.
it yani coil cuts the magnetic field lines when it is rotating in the magnetic field. Okay,
Okay.
the coil, write down please. Coil cuts the magnetic field lines and flux is induced. Flux means magnetic field changes, right? Flux is induced, and then flux is induced. It causes the induced current in the coil. Induced current in coil, or you can say resistor. Both are the right options. Okay, is it clear to you?
Could you explain a little bit more, sir?
Yes, that is that if you are going to rotate a coil in a magnetic field, you know what happens? That happens that it actually cuts the magnetic field line. I mean, let me explain it. Any generator question? Yes. No, it is battery. Wait. Again, motor. This is generator. So here, if I say that um, a student is used mean a handle to rotate the coil. So when the student will rotate the coil, definitely the magnetic field lines will be cut, and due to cutting of magnetic field lines, flux will be induced, or magnetic field will cause the motion of the electrons on the wire to be disturbed, or force on the electrons will be disturbed. That is why the electrons in the coil move. So you have to write the simple mechanism, because there is not the entire principle asked. That's why you will simply write what 1 marks or 2 marks. 2 marks, na? 2 marks का question था ना ये? 2 marks, yes. So for these type of question, you are supposed to write that magnetic field lines are just cut by the coil. Let me explain it to you, because ये topic तो मैं थोड़ा सा डिटेल में पढ़ाने वाला है, इसलिए I will try to make it clear to you. Now this is a coil, and with the help of this coil, we are going to mean this coil is rotated. इस coil को हमने क्या किया हुआ है? It is what? It is rotated. So when you are going to rotate the coil, actually you are doing what? You are applying external force. ठीक है ना? आप देखो क्या कर रही हो? You are going to rotate it by external mechanism. उसने बोला है ना?
Yes.
External mechanism can be a handle, anything. It is rotated like either clockwise or anti-clockwise. It does not matter, and it is connected to, let's say, an external resistor. Right? This is a resistor, or it is now a load. Okay, this is behaving just like a generator. So when this would flow through, or this will move through the magnetic field lines, let's say it is your north, it is your south. So when this coil will move up and down in the magnetic field, it will cut the magnetic field lines, and it will cut the magnetic field lines. What will happen? ड्यू टू कटिंग ऑफ मैग्नेटिक फील्ड लाइंस. अभी तुमने सिर्फ इतना याद रखना है, बिकॉज ये कंप्लीट टॉपिक है जो कम से कम इट टेक्स वन लेसन इंड्यूस्ड ईएमएफ का. सो आई कैन नॉट मेक इट क्लियर टू यू इन डिटेल. अभी तुमने ये चीजें याद रखनी है कि इंड्यूस्ड ईएमएफ इज जनरेटेड ड्यू टू कटिंग ऑफ मैग्नेटिक फील्ड लाइंस. ठीक है, मैग्नेटिक field lines. And write simple words. Don't get yani, don't make it so complicated. देखो, magnetic field lines, when the magnetic field lines would be cut, for example, your magnetic field is from north to south. ठीक है ना? Magnetic field is from north to south. This is the magnetic field. These all are the magnetic field lines. आप क्या कर रही हो? Basically you are moving the coil. For example, I will just draw the position of the coil. It is the magnetic field. ठीक है? And that magnetic field is moving from where to where? From which point to which point? Okay, what is happening?
The screen went white, sir.
Okay, it is actually 1250 time zone. That's why it is white. Actually, it was not white. 1250 पे चली गई थी. Okay, now if I have this is a magnetic field. Yes, I was talking that this is your north, this is your south. So now you are changing. You have a coil in between, right? What you have? You have a coil in between. Coil. What is the function of the coil? Coil is nothing, just like a conductor. देखो, when it will move up and down, what will happen? It will cut more field lines, less field lines, more field lines, less field lines. It is interacting with na. Are you getting my point? Similarly, when
Yes,
it will
sir.
be when it will rotate in the magnetic field line, then again the same mechanism is happening, right? It is rotating in this way. So initially it is cutting just two magnetic field lines. Now it is cutting four, then four, and so on. So when it will rotate, actually it cuts more and more magnetic field lines. So when magnetic field lines are cut by the coil, at that time the electrons inside the coil, they are disturbed. And when the electrons are disturbed, what happens? Those electrons experience they experience a force, and that force make them to move in the coil, and that causes the current in the coil. Now is it clear?
Yes, sir. Now it's clear.
Good. So you have to write in this way. Is this clear? Or should I move to the next question?
Yes, sir.
Okay. It is said that figure 10.1 shows a gap between north pole and south pole of a magnet. North and south of the magnet. The magnetic field in the gap is uniform. On 10.1, draw four field lines to show the pattern of the direction of the magnetic field lines. ठीक है, तो आपने क्या करना है? You have to show four field lines equispaced. This is the beauty of this. ये देखो, आपने 4 फील्ड लाइंस ड्रॉ करनी है. It's if there are 5 you will not be detected, but if there would be 3 you would be penalized. ठीक है? Is it clear to you?
Clear, sir.
So 4 parallel lines with same spacing, या equal spacing. ठीक है? Is it clear to you? Then
Yes,
a
sir.
magnetic field is placed, that is in the magnetic field there is a conductor that shows a horizontal copper wire PQ between the two opposite magnetic poles, north and south is available, and then the current the copper wire is PQ. An emitter is there. देखो, if this is an emitter, I mean there is no battery na. Is it confirmed that there is no battery at all? hmm? ठीक है, बात समझ आ रही है?
Well, since they've not stated anything about a battery, so that means that there is no battery.
I mean, the battery is not connected. You cannot see that there is a battery. There is a load
Yeah.
actually. This is a meter, galvanometer or emitter. So when it is connected, it means that this question is not dealing with the rules of motor. That question is dealing with the rules of induced EMF. ठीक है ना?
Okay.
Okay, so it is said that a circuit may be a circuit made by connecting the sensitive digital emitter. Okay, I was writing sensitive galvanometer to wire is moved vertically downwards. Where are you going to move the wire downwards? State and explain what is being observed on the emitter. State and explain. So you are going to draw. You are going to move this wire downward, right? So force is there. Are you getting? Magnetic field is from north to south. So what would be the direction of current in this one? I told you, na, electrons are not following the rules. So electrons means electronic current. What I told you right 5 minutes back, that this current is due to flow of electrons. So it is called electronic current. So in electronic current, I told you that you will apply left hand rule, but current would move in opposite to the direction
Opposite
of your
direction.
middle finger. Isn't it? Na? Are you,
Yeah.
I mean, do you remember that concept or not?
I do. So whichever like force I'm able to take out, I have to give them the opposite of that for the answer, right?
Yes. So what would be the direction of current according to your understanding?
Okay, so it'll be from P to Q, correct?
Your finger is pointing from P to Q, but I told you that current will be opposite to that.
Yeah, so if my thumb is going upwards right now, the answer should be downwards since it's electronic flow.
Mm-hmm. Actually, you are pointing your thumb downwards or upwards.
I'm pointing it upwards.
Why? Because force is downward, so you have to point your thumb in the downward direction.
But when was this stated?
I mean, then wherever your finger pointing, your finger is pointing this way, na?
Yeah.
It means for your conventional current, this rule is fine. If it would be conventional current, this would be the direction.
So I would take
Are you
the
getting my
opposite of my answer, right? If my answer at the
Yes.
moment is upwards, then you will turn it downwards.
No. It does not matter. But if the direction of current is this way, yani your middle finger is pointing this way, then actually direction of current is this way. देखो मेरी बात सुनो. Force here the you are not asked about force. If you are asked about force and you are given the direction of motion, then you will reverse your थंब मतलब देखो मैं इजी लैंग्वेज में समझाता हूँ. If examiner has given you कि a wire has a current from P to Q, right? Due to motion, where should be it where should it be moved, right? Or what is the direction of motion of the wire to have an induced current? So you will apply the rule, and definitely, where is your thumb pointing according to that concept?
If I move my finger in that way, then it's upwards.
Yani your middle finger is pointing in the direction of green arrow.
Uh, no, I changed it towards the electronic current. You said that we have to point it in that direction, right?
Okay, good.
And my index is pointing towards the south, so then my thumb is going upwards.
Upward. So it means you are going to have the motion on the wire in the downward direction. Is it?
Yes.
Yani to produce the current from Q to P, to produce current, yani electronic current from Q to P, and to produce the electronic current from P to Q in the same magnetic way. If you are going to produce the current from P to Q, okay, what you have to do from P to Q, you have to move the wire upward. Okay, and for this one, move the wire downward because your thumb is pointing upward now. So you have to point your, I mean, you have to move the wire downwards. Are you getting my point? You have to move the wire opposite in direction, right?
Right.
So your thumb is pointing downward or upward when you are getting the direction of electronic current in this way, Q to B.
From Q to P. Um, it's upwards.
Yes, it is upwards now. So thumb is pointing upward. So you when the current is electronic current, your thumb
You
is
take the
not
answer downward.
downwards. Yes, that is why I have written downwards. And if the electronic current is where? If the electronic current is from P to Q, okay, from
P to Q.
P to Q, then apply Fleming's left hand rule for electronic current from P to Q.
Okay. From P to Q. So then it's downwards.
Thumb is pointing downwards, na?
Yeah.
But where should be the actually force?
Then it should be upwards over there.
Upwards. Now you got it?
Yes.
Okay. So this is basically the situation of the I mean the magnetic flux.
Got it.
Sorry, I mean electronic current. Okay, should I?
Understood.
Okay. State and explain what is observed on the emitter. So it is of 3 marks question. So first I will state. State will give you 1 mark, right? Statement mean, or you can just give a heading or not. It does not matter, but you have to state it. ठीक है ना? It. Okay, what is happening, man? It will move or accelerate. Sorry, it will. There would be a deflection on the emitter, or there will be a fluctuation on the emitter. It will move or deflect. Instead of move, just write deflect. What will happen on the emitter? Emitter will have a deflection. The reason, you will get 2 marks for reason, because the magnetic field lines are cut by magnetic field lines are cut by the coil, okay, and it induces a current which is read by the emitter, which is read by emitter. Are you getting my point? Yes, Ariba?
Uh, I'm just reading the thing
Okay,
all over again to make
read it.
sure I understand.
Okay. For every induced current, you have to recall these all. ठीक है कि it will deflect, sorry, because the magnetic field lines are cut by the coil, and it induces the current in the emitter, or in the load, in the resistor, in the bulb.
Got it. Could you give like the exact meaning of deflect though, sir?
Deflection mean motion. Did you ever see the emitter in the real history of
Mm,
your physics life?
once.
Okay, so actually it has a dial, and on that dial there is a needle, and mm, the needle deflects in this way. This is deflection. Do you see the motion of this one?
Yeah.
So initially it would be over there, over here. It will deflect on one side, and then when you will stop it, stop moving the wire, it would stop. And when you will move the wire in opposite direction, it would move in the opposite direction. So this is the deflection. Clear?
Clear.
Okay. State what is observed on the emitter when PQ is moved vertically downwards at greater speed and vertically upward at the same speed as in one. Okay. Vertically downward. Initially, where were you moving that wire? Vertically downward, na?
Really? Yes.
Hmm? So, when you are going to move it vertically downward at the greater speed, as I told you, that the induced current depends upon, our induced EMF is directly proportional to number of turns, directly proportional to speed V. Okay, it depends upon, I mean, it is directly proportional to speed, it directly proportional to area of the coil, and it is directly proportional to B. So, did you ever heard about Nawabs in your Pakistan studies?
I've never taken Pakistan studies before, sir.
MashaAllah, MashaAllah. So, did you ever heard about the lords?
I have.
Yes. So, Nawabs were basically here in subcontinents before division, rather after division also. Anyhow, this is a word you can remember, or you can make your own, because it depends upon different situations. If you are not yani convenient to remember this word, you can make another word for you, but use these four factors to increase the current. So when you are moving it faster. Fast motion, more current. Got it?
Got it.
Fast motion, more current. Number of turns and all that stuff. So it will have more deflection as magnetic field lines are cut at faster rate. Okay? Magnetic field lines are cut at faster rate. Okay? Is it clear to you? And when you are going to move it vertically upward at the same speed, so its deflection will be reversed. As I told you, that when the direction of motion is reversed, the deflection, I mean direction of current is reversed. Deflection of emitter is reversed. Okay?
Could you explain the Nawab thing a little bit more, sir?
Nawab is nothing. Just forget about it. N is number of turns. B is speed. Okay? A is area. B is magnetic flux density, magnetic field. So these are four factors which increases the induced EMF.
Got it.
Factors affecting induced voltages are induced EMF. So N mean number of turns, V mean speed, A mean area of the coil, B is the flux density, magnetic flux. ठीक है, magnetic field कह सकते हो आप. And B is increased by adding core into the coil. When you are going to add a core into the coil, actually what are you doing? You are increasing the magnetic field strength. Okay?
Okay.
Okay. The next is ट्रांसफार्मर क्वेश्चन. ट्रांसफार्मर में तो तुम्हें मैंने बहुत सारा कुछ सिखाया हुआ है, and I believe that you will be able to do that. Okay, figure 9.1 shows separate coil of the wire wound around an iron core. Okay, there are two coils. One is the secondary coil, one is the primary coil. So do you see the number of turns on the primary coil are greater than number of turns on the secondary coil? So it means it is step down, is it?
Yeah.
Okay. State the name of the device. Transformer. Okay. Explain why there is a current in the lamp. So where is the lamp connected? That input is connected to a 12-volt power supply. Okay. Sorry. The AC supply is connected across the primary coil, and a 12-volt lamp is connected across the secondary coil. Here is the lamp, and that lamp works on a power supply of 12 volts. Okay, that is connected with an AC supply, and he has not given us any value of that. But the game is why there is the lamp, why the lamp is working. So why is the lamp working? We explain it in detail that the alternating current in the primary coil or alternating voltage in the primary coil, they cause an alternating magnetic field in the coil. Got it? You have to write 3 points for that one or 4 points. Alternating current in primary coil. बेटा ये याद करना पड़ेगा. Primary coil.
There's no trick for this one, sir?
No. Causes an alternating magnetic field. This is actually a comprehensive theory part. So I need some space. हाँ मैं यहाँ लिख रहा हूँ, ठीक है? I'm going to write its answer here. It is under the heading
Okay.
of working principle of transformer, right? What I'm going to write now, working principle of transformer. You can score at least 5 marks if you will add all these points there. It depends that examiner is awarding you 3, 4, or whatever. So first of all, you will write that an alternating current in the primary coil. You will write all these points step by step when it will be asked that how does the transformer work, or how output coil gets voltages, or how the lamp works at the primary coil, etc., etc. An alternating current causes an alternating magnetic field in the primary coil. ठीक है? Magnetic field in primary coil. Is this first thing clear to you?
Yes, sir. Could you please just excuse me for 1 sec? It's a bit urgent.
Yes, yes.
Thank
Sure.
you.
Um,
Back, sir.
Okay, I have written all these points that the magnetic flux, the magnet alternating current is caused on the alternate that causes an alternating magnetic field in the primary coil. The magnetic field lines are linked to the secondary coil through core. This is actually the function of core, right? This one. This is the function of core also. So core links the magnetic field lines from primary to secondary coil. I will show you on the diagram as well. Then when this alternating field lines are cut by the secondary coil and EMF is induced in the secondary coil, right? You have to write all these 4 points. Okay?
Okay.
Yes, you have to recall them. Yani hips karna hai. Without that, there is no other choice.
So, like, memorize these.
Yes, yes, yes. Recall them all. This is the working principle. No? So principles are recalled. It is asked to you. Take this is not a technical thing. You have to remember that what happens. There is an there is a variable current at the input coil because alternating current है ना ये. So when the current is alternating at the input coil, the same current is actually fed to the that current provides an alternating magnetic field because magnetic field is directly proportional to the current. Third, that field then passes through the secondary coil, and that is done or that linkage is provided by the core. Core links the magnetic field lines of primary coil to the secondary coil, and in this way the secondary coil, I mean magnetic field which is varied in the primary, it reaches to the secondary and then it is cut by the secondary coil, and when they are cut the EMF is induced. Okay.
Okay, sir.
Okay, so this was the principle which you have to write here. Now you have to solve the question for 2 marks. The coil is connected in such a way that is, yes, there are connected to a lamp has 450 turns. So it means these are the number of turns on the secondary coil. The EMF is 240 volts because primary coil is connected to that. That is why it is VP. Calculate the number of turns on the secondary coil. I mean connected to the AC. तो आपने क्या करना है? You have to find out the number of turns. And number of turns के लिए we have learned one equation if you remember. है ना? NS divided by NP is equals to VS divided by VP. Is it?
Yes, sir.
Do you remember that equation? So number
Yes.
of turns on the secondary are given 450. Number of turns on the primary are unknown. So just write it NP. Secondary coil voltage are 12 volt because that was given in the first part that lamp is connected to a 12 volt lamp is connected and then it is 240. So just calculate it for NP. NP is equals to 240 into 450 divided by 12. Okay, so 12 ones are 12, 40. So it would be 9000 tons. Okay,
Could I look at the diagram one time, sir? Because I'm a bit confused on how you know which is the primary and which is the secondary.
actually, it is mentioned in the information that an AC supply is connected across the primary coil and a 12-volt lamp is connected across the secondary coil. Here is that all information. Is it clear to you?
Yes, sir. I've got it now.
Okay, good. So yeah, the last part, then 240 DC supply is used instead of 240 AC supply. Tick one box that indicate what will happen to the lamp. So what will happen to the lamp? As I told you, that variable magnetic field is required. What happens? I mean, if for working of transformer, we need a variable power supply. So DC will not work. So this is incorrect. This is incorrect. This is incorrect. This is the correct. Nothing happens. I'm explaining it for you because although it is not required, no variation in magnetic field. So no EMF, right? So no EMF, lamp does not glow.
Got it.
ठीक है. ओके, एक ये वाला क्वेश्चन बस और कर लेते हैं, देन वी विल डू इन द नेक्स्ट पार्ट, नेक्स्ट क्लास. Correct. A simple motor is made to a school laboratory. The coil is a coil of wire is mounted on the axle between the poles of the horseshoe magnet. At an instant illustrated in figure, the coil ABCD is horizontal. The battery is connected as shown in the figure. ठीक है जी, battery is connected as shown in the figure. For the position, state the direction of force on side AB. State force on AB and direction of motion of AB बताना आप. Yes, what will be force on AB or what will be the direction of force on AB?
Okay,
करंट
so
कहाँ से कहाँ जा रहा है? करंट इज मूविंग इन दिस वे.
BA to
तो
B.
आपकी
If I want my index to be pointing in that direction, and I'm using my left hand, I would have to turn my hand, and the force is downwards.
yes, exactly. Okay, and when the force will be downward, it will be rotating anti-clockwise. है ना?
Yes.
And rotation is anti-clockwise. Yani downward because it is not for the coil. Direction of motion is also downward. And explain why the BC does not contribute to the force on the coil. So go to that side BC. BC is parallel to the magnetic field, right? Did you see that? ये देखो. BC is parallel to the magnetic field line. That is why it will not have or it will not experience any force. When the wire is parallel to the magnetic field lines, it does not experience a force. आप अपने फिंगर्स को पैरेलल करके देखें जरा. Will you be able to make current and magnetic field parallel? And if they are parallel, do you able to apply Fleming's left hand rule? देखो
Wait.
पैरेलल हो ही नहीं सकता ना. पैरेलल हो ही नहीं सकता because for
Yeah, because
Fleming left
the
hand rule we
use
have
the
to
left
keep
hand
them
rule, it has to be
perpendicular.
perpendicular.
Yes. So no force at all. And the motor in figure 9.9 does not rotate very quickly. The designer of the commercial motor is required to produce fast rotating motor. So just one change that could be made to increase the speed of the motor. The speed of the motor के लिए हम लोग क्या करते हैं? I told you, N either increase N, either increase A, either increase B, either increase I. So what would be convenient here? Any one from these four factors you can write. So increase the current in the coil. That will give you mark. Increase number of turns, increase area of the coil, increase magnetic flux density, or insert core into the coil. So that is, you can do it quite easily. ठीक है, बाकी क्वेश्चंस हम लोग नेक्स्ट सेशन में करेंगे इंशाल्लाह.
Okay, sir, inshallah.
Yeah. In one more lesson it would be done inshallah. And just आपने ये करना है कि what we have learned, just keep in touch with that.
Okay, sir, I've got it.
Yes. See you then. You have any
See,
question?
no question, sir. Thank you so much.
Okay, my brother. See you then.
See you, sir. Allah Hafiz.